Hello and welcome to another one of D's ADD videos. Today we're going to look at the concept of integrated rate laws by checking out this example. Here we have a solution that has a 1.2 molarity, and experimentally you derive that the rate constant is 3.2 times 10 to the negative 6 seconds inverse. And you're asked to determine the concentration remaining after 4.5 hours. So right away you should see this as an integrated rate law problem because they're asking for concentration at time t. So the next question you should have is, what order reaction is this? Is it 0, first, second? They didn't specify. How do you determine that? Well, the way you determine that is by the clue they gave you, the rate constant. See how the rate constant is seconds inverse? Because it's second inverse, you know that this is a first order reaction. Now you know that, you know what equation is feasible. Corrected? So anytime the question is how much is left at time t, you're looking for A sub t, the concentration at t. And because the reaction's first order, the equation becomes this. There's also the other version of this equation. Remember, natural log and E are inverses of each other. So you might see the equation written as ln of AT over A naught. But if you were to E both sides and multiply by A naught, you get this equation. I just prefer it. It looks neater to me. Whatever your preference is, go ahead and stick to it, okay? They are the same equation. So now, when I plug in, I have the original molarity, and I plug in my rate constant K, which goes up here in the exponent. And once I plug those things in, I realized that I need my time in seconds, and I wanted 4.5 hours. So what you have to do is you have to convert the 4.5 hours into seconds. So you use your conversions. Whatever you have goes on the bottom. Whatever you want goes on top. Have, want. That way, whenever you're doing this, you can cancel out and be left with the correct units that you need, which is seconds. So when you plug in the 16,200 seconds, which is the 4.5 hours, you get this wonderful equation here. And you hopefully aren't one of those people that just plugs all that into a calculator. There's too many little sources of error there. I like to do it a little bit by bit, so multiply these two here, you should get that. And then after you take e to the negative 0.05184, you should get this number here, then multiply it to get that. Since 1.2 was 2 sig figs, I went ahead and rounded it down to 1.1 because that 3 is less than a 5. Alright? And that's basically it. Check out part 2 of this video when we look at the half-life. Again, because we know the units of K, we know it's first order. If you want to go ahead and practice, see if you can do it on your own. We will be doing that problem here in a little bit. Okay? Hope I've eliminated any doubts you might have over the basics of integrated rate laws. Practice, practice, practice is the key to understanding all this material and no longer having any anxiety issues on exams. All right? Thank you and have a nice day.